Yeah, hi, good evening, everyone. So this session is related to ML, machine learning mod. So we are going to study about the basic of machine learning, what is supervised machine learning, what is unsupervised machine learning, what all models that are present for supervised and what all which are present for unsupervised. So before starting this session, let me first introduce myself. Let me open my LinkedIn profile so that you will get an idea regarding this. So my name is Paras Kumar Gupta. I hold a bachelor and master degree from NIT Durgapur, master degree in mathematics and bachelor degree in mechanical. So let's quickly, this is my short introduction. Let's quickly start with our machine learning. So before starting machine learning, we need to understand what is this ML all about. Let's start with the structure of machine learning, the diagram which is used to classify what is AI, what is machine learning, what is deep learning, what is generative AI and all. So you need to understand all those basic concepts, then only you will be more clear about the different classes from which we are extracting the signal. So basically, first we will draw a diagram related to what is AI, ML, DL and all. So first is AI. All this ML, DL and all comes inside this AI. This is my AI, stands for artificial intelligence. Inside this AI, we are having ML. This inside this, we are having ML. Inside this ML, we are having DL, deep learning. And finally, we are having GenAI. So we will go and study about each and everything. We will see the definition of each and everything so that it will be more clear to you guys what is AI, ML, DL, and GenAI. So let's first start with AI. AI stands for artificial intelligence. So if I ask you what is this AI all about, this AI is nothing but it helps us in automating human intelligence. For example, how self-driving car works. It is the working principle of self-driving is nothing but some AI agent is there which has the capacity to think like a human being. In the same way, we have different robots and all. What is this robot do? They help us in uh, acting like a human being, how human behave in different circumstances. We will try to replicate the same thing by using this AI, artificial intelligence. So when it comes to AI, it is to automate human intelligence. It is to, we can write, it is to automate the human intelligence. Inside the umbrella of AI, we are having ML, machine learning. So when it comes to machine learning, when we talk about machine learning, what we are doing, we are trying to find the pattern that is present inside the data so that we can predict the future. But you can say, you can ask me one question that we can find the pattern by using simple coding language, what software engineers generally do. So what is the role of this machine learning? How we emphasize more on this machine learning to predict the future or predict the past value too. So the role of ML is we don't have to explicitly program the model. We don't have to explicitly program the model. The model, by understanding the pattern present inside the data, it will try to predict it. Here we are not explicitly programmed. For example, let's suppose if I write what is the equation of straight line. We all know that the equation of the straight line is y equals to mx plus c. This is the equation of the straight line. We will try to create this equation and draw a straight line, which help us in finding the unknowns, like finding the pattern present in the data and then predicting the outcome. But when it comes to very complex data, we are having this complexities like this. So if we are having a very complex data, it is very difficult to find the equation of this curvilinear. Let's suppose this is my exact curvilinear path. It is very complex to find this curvilinear path. We don't have exact equation to find this curvilinear path. We can get any kind of structure of the data. So for any kind of structure of the data, we will not go and find a particular equation to solve this problem. To resolve this issue, we came up with a solution of ML. Here what happened? According to the pattern present in the data, the model will understand it and predict it. So there is no hard and fast rule of using any particular equation, and we don't have to explicitly program it. So when it comes to the definition of ML, here we can say that when it comes to ML, machine learning, it is used to find the pattern present in the data without being explicitly programmed. We can write here, it is used to find the pattern present in the data without being explicitly programmed. Here what's going on? We will only, we have multiple different types of machine learning model. What we will do, we will just feed this data. We will just feed this pattern of the data and let the model understand the pattern and then predict the outcome. Here we are not using any hard and fast equation and then we write the code for it that it should be a straight line. There can be any pattern. Although we also have linear regression, logistic regression, where we had having an equation to create a straight line or sigmoidal line. But when it comes to machine learning, we can create any kind of pattern. We can try to find any kind of pattern and we can predict the future without being explicitly programmed. So finally, what's going on? We will just feed that, let the model understand what is going on, and then it will automatically by itself find the pattern present in the data. So that's why we have written here without being explicitly programmed. It is used to find the pattern present in the data without being explicitly programmed. Now, inside the umbrella of ML, inside this umbrella of ML, we are having deep learning. Now let's talk about what is this deep learning. So when it comes to deep learning, it is basically used to find the solution related to audio data, video data, image data, and text data. So basically, when it comes to data, the data will get classified into several parts. But here we focus more on structured data, semi-structured data, and unstructured. So when it comes to structured data, if we can write the data in tabular format in its raw form, if the data is in its raw form and we are able to put it in table, we can say it is a structured data. If the data is present in its raw form, and if we are able to put it in table, we can call it as structured data. When it comes to semi-structured data, if the data is not present, if it is not possible to put the data in table when it is in its raw form, we call it as semi-structured. But it's very easy to convert a semi-structured data into structured data. It's very easy to convert this semi-structured data into structured data. For example, JSON data, .json. JSON in the form key value pair. You might study it in your Python session. What is key value pair? Like dictionary format of data, we put it in JSON format, and it's very easy to convert this JSON format into a structure form. But when it comes to yeah, of course. So if you have any question, you can put it in chat. Now, when it comes to unstructured data, when the data, when it is not possible to store the data in its raw form in tabular format, then we call it as semi-structured data. It's it's difficult to convert. Okay. It's very difficult to convert this unstructured data into structured data. I'm saying it's difficult to convert, but I'm not saying it's impossible. We can convert this unstructured data into semi-structured form. For example, unstructured data example are audio data, audio, video, text. These are image, you can say image. These are example of semi-structured data. It's very difficult to convert this data into structure form. So most of the basic ML model is work on structured data. Basic ML model, it might be linear model, logistic model, SVM and all. These are very basic model, and we use those model for structured data. But what about unstructured data? What about unstructured data? So to deal with this unstructured data, we came up with an idea of deep learning. So to deal with this unstructured data, we came up with an idea of deep learning. So let me write the definition of deep learning itself. Deep learning. So when it comes to deep learning, it helps us in dealing with those unstructured data. Let me write the definition of deep learning itself. It is used to build an AI solution related to image data, audio data, and video data. When it comes to ML, basic ML model, it basically work on structured data. But when it comes to deep learning, it is used to build an AI solution related to image, audio, or video. So let's write it. It is used to build AI solution related to video, image, audio, or text data. You can write or text. Now, inside the umbrella of deep learning, till now we have discussed what is AI, what is ML, what is DL. Inside the umbrella of deep learning, we are having Gen AI. So when it comes to Gen AI, it is used to generate audio, video, or image data. When it comes to deep learning, it is used to find the solution related to audio, video, or image data. But when it comes to Gen AI, when it comes to Gen AI, generative AI, it is used to generate audio, video, or image data. We can write here, it is used to generate audio, video, or text data. So these are all the definition when it comes to what is AI, what is ML, what is DL, and what is GenAI. So when it comes to AI, it is help in automating human intelligence, how human being thinks. If you want to automate those thinking of the human being, we will go for AI. Inside the umbrella of AI, we are having ML. So when it comes to ML, we will get very complex data. And we will not have sufficient kind of equation to create this line for the complex data. So what we will do over there, we will just feed the data to the model. Model by itself understand what is going inside the data, and then it will find the pattern present in the data. So what's going on? We are not explicitly programmed the model. We let the model understand the pattern and then decide what is the appropriate prediction for the pattern. When it comes to deep learning, here, what's going on? In most of the ML model, most of the basic ML model, that logistic regression, linear regression, SVM, KNN, DB scan, for all those, we are dealing with structured data. But what about unstructured data? What about very complex data? So to deal with those unstructured data, we've come up with an idea of deep learning. So in deep learning, we basically deal with audio, image, video, and text, which the data which is very difficult to convert into structure format. It's very difficult to convert a video into structure format. So to deal with those kind of data, we come up with an idea of deep learning. And inside the umbrella of deep learning, we are having Gen AI, which is used to generate audio, video, or textual data, like ChatGPT. ChatGPT helps us in generating audio, video, or image, or text data. So this is all the classification of my different classes. You need to be very clear regarding all this. Then only you can understand what's going on in ML. Now let's start with ML. Once we have once we understood the what is AI, ML, DL, and Gen AI, now we can proceed with understanding what is this ML. ML, basically machine learning, classified into three parts. Machine learning basically classified into three parts. First one is supervised. Second one is unsupervised. And third one, we can say reinforcement learning. So we will not focus more on reinforcement learning here. When it comes to reinforcement learning, we will not feed any data. We will just, according to the situation, model will understand what is good or bad. In this case, we will not focus on feeding the data. But in these two cases, we will understand the pattern by feeding the data. Here, for this, we can imagine that in a island, let's suppose we left one boy. It's a 5-year boy, 5-year-old boy. What it will do, it will perform, it will go and start searching for food and all. He don't have any skill doing so things. So what we will do, either we will guide it. The person will follow one step. Let's suppose the person follow one step. Then we will guide him that it's a good step or bad step. We will only give the result that it's a good step or bad step. We will not feed any kind of knowledge to this person that you have to do like this or do like that. So here data is not present. Basically, we will not feed much data while learning the pattern. Here we focus more on supervised and unsupervised. So let's start with unsupervised machine learning model. Okay. Let's start with unsupervised machine learning model. Unsupervised. So when it comes to unsupervised machine learning model, we simply say when the target column is not given, you can write when the target column is not given, then we will go for unsupervised machine learning. Here we can say when the target column, or we can say feature, is given, then we will go for supervised. Now the question arises, what is this target column? What is this target column we are talking about? When it comes to having a data, we are having multiple data. Let's suppose we can have in a data, we can have multiple columns. There are multiple columns. In this column, if we have x1, x2, x3, and y. For example, we can consider that we are performing forecasting of whether today we are having rain or not. Yes or no? Whether we will uh, have rain in Bangalore or not. So we will get certain criteria to consider, like what is the humidity, what is the temperature, like what is the wind speed. Here we can write humidity. This can consider as humidity. There we can consider as temperature, wind speed. In the same way, we can have cloud also, that whether we are having dark cloud or not. So there are multiple. I'm just trying to make it as easy as possible. There are very complex data which we will consider while predicting, not predicting, forecasting, whether we are having rain or not. But I'm trying to make it simplify. We are having humidity, temperature, and wind speed, and we are trying to figure out whether we are having rain or not. Yes or no. Yes or no. So if you think carefully, this this column, whether it is having yes or no, it's totally depend upon these columns. These columns. Humidity, temperature, and wind speed. If the humidity is more, wind speed is more, temperature is less or moderate, we can have rain. If the humidity is very less, temperature is very high, wind speed is very low, we don't have rain. So if you think about it, this column, this prediction, yes or no, is totally depend upon this. That's why we call all these three as a independent column. This is called as independent. And this is called as dependent. So when it comes to data science, we can write here column, or it can have features, independent features and dependent feature. Now, if there is a scenario where your dependent feature is given, the target is given, then we will go for supervised machine learning model. If there are situations in which the target Y is not given, then we will go for unsupervised machine learning model. That is what written over here. When the target is not given, we will go for unsupervised machine learning model. When the target is given, we will go for supervised ML model. Now, let's talk about the structure by which we will able to classify what is the structure which we follow for any supervised machine learning model or unsupervised machine learning. So let's go with the structure. This one. Let's go now. Okay, this one. Ah, got it. Got it. So we got. Let's deal with the structure of supervised machine learning model and uh, unsupervised machine learning model. So let's first deal with the structure of supervised ML. So when it comes to supervised ML model, we will get the data. Let's suppose I got the data. This is my data set. And we all know that we have X, all this independent column, and Y. When it comes to supervised machine learning, we have Y. If Y is given, we will go for supervised machine learning model. Here, what we will do, we will split the data into two parts. We will split the data into two parts. This is my train data, and this will become my validation data. And there are multiple methods by which we will split the data. Like let's see it in. Let's see it over here. So what we will do, if we are dealing with supervised machine learning ML model, here target is given. Target feature is given. What we will do, we will go for splitting the data into multiple. This will become my x1, x2, x3, x4. And this is y. We split it into two parts. We call it as x train, y train, x test, and y test. And after splitting it, we again split the train data into two parts. We call it as x validation, y validation. We split it into this many parts. Now we will feed all this to model, not this to. We will feed only this to our ML model, and then to check whether the model is learned properly or not, we will go with this X validation. Okay. First, we will feed this data to the model. The model will find and learn pattern present in the data, and then we will give this data to the model, and model will check what is the accuracy that you are getting. Is it a correct prediction? Whether the model is able to learn the pattern properly or not? For that, we will go for validation. And then for testing purpose, again, we will feed this test data to the model so that the model will go and try to find, so that the model will go and try to give the outcome in totally unseen data. When it comes to test data, we call it as unseen data. Because model didn't know about this data, unseen data. It's totally new to the model. When it comes to validation, somehow model managed to see the validation data and all. But when it comes to test data, the data is totally unseen to the model. Model didn't know about this data. The model never saw this data before. Whatever the accuracy that we will get while performing this task, we will call it as train accuracy. Whatever the accuracy that we will go, that we will for this, we call it as test accuracy. So here also, if you see, what we have done, we split the data into two parts. We split the data into two parts: train dataset and validation dataset. We have some historical data. We get some historical data and we call it as population data. It's a very huge amount of data that we are getting. What we will do, we will convert it into different sample. We are having simple random sampling, stratified sampling, systematic sampling, convenience sampling. So there are multiple sampling technique from which we will try to extract sample out of population. There are multiple different types of sampling technique using which we can try to extract sample out of population. Once we extract sample out of the population, we will split the data into two parts, train and validation. The train part, we feed it to our machine learning model. Okay, we will feed our train data set to machine learning model. Once it's done, again we will see machine learning model is nothing but a mathematical equation which help us in finding the pattern present in the data. So when it comes to ML, machine learning is nothing but a mathematical equation which help us in finding the pattern present in the data. ML model will go with their own ML mathematical equation and predict something, that whether it is going to rain today or not. Then we will feed the validation data and check how accurate our model is. The model predicts something, and then we have our validation data which help us in finding how accurate my model is. After that, we will store it somewhere. Let's suppose I got an accuracy of 70%. That my model is 70% accurate in predicting whether tomorrow it is going to rain or not. This is called as train accuracy. Whatever accuracy that you are getting, 70% accurate. This is called as train accuracy. In the same way, let's suppose we are getting new data. It's totally new data. We call it as totally unseen data. Model didn't know about this data. Again, we will get this model because model have learned the pattern that is present inside the data. We will get the same model, but that is mathematical equation, and feed totally unseen data. It's totally new to the model. And once we feed it, it will give us some sort of prediction that whether we are having rain or not. Let's suppose we get a prediction of 68%. Now the model, when we feed completely new data to the model, model will predict with 68% of accuracy, although it's not a very good accuracy. But for assumption, we are considering it that if we are feeding totally new data to the model, model will give us a prediction with a 68% of accuracy. In the same way, if we feed validation data, model will give a prediction with an accuracy of 70%. This is called as train accuracy. And this is called as test accuracy. This is called as train accuracy. This is called as test accuracy. So I hope this image is clear to everyone. Now let's proceed with unsupervised machine learning. This is the structure which we follow when it comes to supervised ML model. Now if we think about unsupervised ML model, let's talk about unsupervised. So when it comes to unsupervised ML model, here y is not there. We don't need the target column. Here we basically try to cluster down. For example, let's suppose we are trying to perform a project related to Netflix recommendation engine. like which kind of movie to recommend to which kind of people. So basically, we will gather the information of person one. We will gather the information on the person one, like whether the person like. Uh, let's make it properly. Here, what we will do, we will gather the information of the person one, that whether he like old movie or no, new, old or new. Uh, what kind of genre of movie? Is it comedy? What kind of genre of movie the person like? What is the age of the person? Age of the person. From which region it belongs to? Maybe it belongs to east side of India. You never know from which region the person belongs to. So this is person one, two, three, four, and it will go on. So we will get information of different person. We will get information of the different person, and we will try to cluster down the person according to the similarity, like recommendation engine, movie recommendation engine, or uh, food recommendation or clothes recommendation. All this work in this phenomenon. What it will do, it will cluster down the person according to the data that we are having. If we are having similar kind of data, we will cluster down that person. Let's suppose 1, 2, and 3 comes in one cluster. Then 4, 5, 6 comes under another cluster. So according to the data, we will cluster down the person. This is the work of unsupervised ML model. And if you think about it, here we don't have target column. We don't have any Y which indicate whether we are having rain or not. Here we are trying to cluster on the person according to the similarity of the person, or cluster on the food product according to the similarity. For example, if we talk about egg and milk, we can cluster them together, or bread and butter. We can cluster them together. Or toothpaste and brush. We can cluster them together. But we can't cluster any very dissimilar product. Let's suppose vegetable and toothpaste. We can't cluster them together because there is a lot of dissimilarity between vegetable and toothpaste. So according to the similarity, we will go and cluster down the data. For that, we will go with unsupervised ML model. Whenever we have to deal with the clustering of the data, we will go with unsupervised machine learning model. So I hope it's clear that what is the use of unsupervised machine learning model. Now what we will do, we will go with structure. Like what is the structure that we are going with unsupervised machine learning model. So when it comes to unsupervised, we will have trained data and prediction. We have historical data. We will feed this historical data to unsupervised machine learning model. There are multiple. Like we are having k-means clustering, db-scanned clustering, hierarchical clustering. And then we will go find the pattern present in the data. Once we find the pattern present in the data, we will cluster down the data. Once we find the pattern present in the data, we will cluster down the data. Now, once we get complete new data set, let's suppose we are getting completely new data set. Again, according to the rule and pattern that we have learned in this ML model through this data set, we will feed that pattern that we have learned to the new data set for further prediction. That let's suppose a new person will come. In which group that person belongs to? In which category of a person, or in which group that person belongs to? For that prediction, we will go and use unsupervised machine learning model. So this is very simple cluster 101, where we are trying to cluster similar kind of item. If they are very close to each other, if the items are very close to each other, we will create a cluster. And if it is far away, we will put it into different cluster. So it's saying similar items should group together. We're having similar item. We should group together the similar item. And the dissimilar item will be grouped in different groups. Now, if you are having only one feature to consider, here the feature is age. If you are having only one age column to consider, then we will create box plot. It is very easy. We know that box plot helps us in finding the outliers. And at the same time, it also helps us in finding the distribution of the data. This box plot helps us in finding the outlier, and at the same time, it helps us in finding the distribution of the data. If we are having two features, then we will go with scatter plot. Scatter plot helps us in finding the co-similarity or correlationship between the two data. This scatter plot helps us in finding the co-similarity, and then we will go with finding the distance between the data points. So to cluster down the data, we need to find the different distance between the data. Then only we can group them together. So this is cluster 101. If you see, there are 1 and 7 are grouped together because these two are similar to each other. That if you see, both are having sex as male, both having glasses, both having mustache, both is smiling, and both is having hair. So we can say that this 1 and 7 comes under one group. In the same way, if you see 10 and 12, both is female, both don't have glasses, both don't have mustache, both are not smiling, both don't have hair. These two are similar. So we can indicate that these two are similar. This is a very basic clustering technique that we have. Now, once comes to hierarchical clustering, we will see the hierarchical clustering in detail. Not here. I will let you know where to see the hierarchical clustering. Here. Imagine that we got a very simple data set. Which indicates x1, y1, and the items that we are having. So here we are having x1, y1, and the items that we are having. What we can do, we will go with scatter plot. We can plot it. We can put it as x1 and make it as x2. Now we can plot, this is 1, 1. So one data point will come here. 2, 1, one data point will come here. 4, 5, 4, 5, one data point will come here. 7, 7, 7, 7, one data point will come here. 5, 7, one data point will come here. We can make a scatter plot. We got very simple data set. We can create a scatter plot out of it. Now, once we this scatter plot is done, what we can do, we will try to find the distance of one data point with all the other data points. We will try to find the distance of one data point with all the other data points that we have. No, now how to find this? How to find the distance of one data point with all the other data points? To find it, we are having multiple distance calculation formula. There are so many. If both are numerical, if both data that we got, these are numerical, then we will go with numerical distance formula. Let me write here. We are having numeric distance formula. These are called as Euclidean distance. You might be familiar with this Euclidean distance. If you want to find the distance from two data points, let's suppose I am trying to find the distance of this with this. We are having this as 1, 1, and here we are having 2, 1, 1, 1 and 2, 1. So if you are having this kind of data, what we will do, we will perform 1 minus 2 whole square plus 1 minus 2 whole square, that is root under. This is nothing but Euclidean distance, EUC, Euclidean distance. Whenever we are trying to find the distance by using this formula, x1 minus x2 whole square plus y1 minus y2 whole square, x1 minus x2 whole square plus y1 minus y2 whole square. We will call it as Euclidean distance. We will use this formula to find the distance. So this, I guess, most of you might know about this Euclidean distance. Then after, we are having Manhattan distance. Manhattan distance. If you want to find the distance by using Manhattan distance, it will be x1 minus x2 mod plus y1 minus y2 mod. This is nothing but Manhattan distance. So if you want to find the distance from A to B to C to D, you can directly find from here to here. You can directly go and find from here to here by using Euclidean distance formula. This is also called as crow-fly distance because here we are finding the shortest path between two data points. But what if I, instead of going directly jumping from here to here, what if we go at this point, A, B, C? And distance will become AB plus BC. If I'm going through this distance, we call it as Manhattan distance. If I follow this kind of distance pattern, we call it as Manhattan distance. Now, when it comes to Manhattan distance, why we generally, why not directly jump from A to B, A to C? We can jump from A to C directly. Why we are following this path of going from A to B and then B to C? See, why we are doing it? Because sometimes what happens, we can't directly jump from A to B. For example, let's suppose you order some food from Zomato and this is your hotel. Hotel from where you have ordered Zomato food and this is your home. Now the Zomato guy will not directly fly from here to here and follow the shortest path. No, it will not do. It will follow, the person will follow the path, the road path. Let's suppose the road is like this. It will not directly jump from A to B. It should follow the path. So to follow this path, we will go with Manhattan distance. This is also called as city block distance. Manhattan distance is also called as city block distance, where we will follow the path according to the road. Will not directly jump from A to B. Yes, we can do it in flights. We will go with the shortest path of the flight, but we can't do the same in roads. We can't jump from one building to another building. So to do it, we will use Manhattan distance. After this distance formula, we also have Mahalunam's distance. We also have Mahalunam's distance and Minkowski distance. If you see Mahalunam's distance, it is the general version of Euclidean distance. If you generalize way of writing the Euclidean distance. When we have Euclidean distance, we have x1 minus x2 whole square plus y1 minus y2 whole square. Then we can say that this is Euclidean distance. If I write like this, x1 minus x2 power p plus y1 minus y2 whole to the power 1 by p. So if you think here in Euclidean distance, p value is 2. But if you generalize this, that you can put any value in place of p, we can say that it is a Mahalunam's distance. Mahalunam's distance. This distance we use for Euclidean, this numerical values. All this distance we are using for numerical values. Now, what about this categorical value? What if we are having categorical data and we want to find the distance? Can I have categorical data and it's possible to find the distance between categorical data? So to find the distance for the categorical data, let me write here, categorical, we are having binary Euclidean distance. Distance. Now let's suppose the category is binary. We have categorical data, but those categorical data is in the binary form, in the form of yes and no. You can consider yes as 1, no as 0. If you consider yes as 1, no as 0, you can use this binary Euclidean distance to proceed further. After binary Euclidean distance, we are also having simple matching coefficient. After this binary Euclidean distance, we are having simple matching coefficient, which help us in finding the distance between binary data. Till now, we are dealing with binary data. And similar to this, we are having Jacquard's index. Now, what is the use of all this? Why we are having multiple distance formula? Let's take one example of binary categorical data, and then it will be more clear. Imagine that we are having one uh, example, person 1 and person 2. And I want to find the similarity between these two persons. My main aim is to finding the similarity between these two persons. If it is written that both like movies, yes and yes. If it is saying that both does not like uh, sports, no, no. Both person does not like sports. Both person likes movie. One person, let's male or female. One person is male, yes, male. One person is female. You can write no. And at the end, let me write it. P1, P2. Like both are from same location. Let's suppose I'm writing Bangalore. Both are from Bangalore. We can say uh, no and yes. So here in this condition, what we can do, write, we can consider yes as 1, no as 0. Yes as 1, no as 0. And we can directly use this Euclidean distance formula. We can write distance equals root under. We are having no, we have considered no as 0. We have yes, we have considered yes as 1. We can write 0 minus 1 whole square. Plus yes and yes, we can write 1 minus 1 whole square. No and no, we can write 0 minus 0 whole square. In the same way, we can write 1 minus 0 whole square. So what I did, we have binary categorical data. Okay, we have binary categorical data and we easily figure out what is the distance between person 1 and person 2 by using this binary Euclidean distance. In the same way, we can go with simple matching coefficients. So to deal with this simple matching coefficient, for this simple matching coefficient, we will create person 1, person 2. Here we can write yes, yes, no. And we will write here yes, yes as 1. One case we are having both as yes. One case. One case in which we both have no. No, no. One case person 1 is having no, person 2 is having yes. 1 and 1. When it comes to simple matching coefficient, it will consider this 2. It will consider this 2. Yes, yes, no, no. How many yes, yes are there? We are having 1 yes, yes. Plus how many no, no are there? We are having 1 no. And then after we will divide it with all the values that is present over here. 1 plus 1 plus 1 plus 1. Finally, we are getting 2 divided by 4. This is my simple matching coefficients. That's how we are able to find the distance by using simple matching coefficients. Similar to this, we also have Jacquard's index. Okay, similar to this, we also have Jacquard's index. Now, when it comes to Jacquard's index, we will not consider this no-no. If they don't, if 2% does not like sports, okay, listen to this carefully. If 2% does not like sport, it does not mean that these 2% are similar. If two-person does not like sports, it does not mean that these two-person are similar to each other. That's why in Jacquard's index, we will remove this no. We will only consider all these three. So when it comes to Jacquard's, how many yes, yes are there? We are having one. Divided by how many total number of data points are there? One, one, one. Three. We will not consider this. Why we are not considering? Because if two-person does not like one thing, it does not mean that these two-person are equal. If two-person does not like one thing, it does not mean that these two-person are equal. This is what happened in Jacquard's index. Similar to this, now we have completed our numerical call. How to find the distance? When the data are numerical, we have completed what happen if the data are binary. How to deal with the binary data? Like yes or no, Boolean kind of data. But what will happen if we are having mixture of data, both categorical data and numerical data? When we are having both categorical and numerical data, what will happen? So let's see, when we are having both categorical and numerical data, we come up with an idea of Gover's general dissimilarity. When both data are categorical, mixture of, if the both data are mixture of categorical and numerical, we go with Gover's general dissimilarity. Yes. So what is this Gover general dissimilarity? Imagine we are having multiple columns and I want to find the distance between person 1 and person 2 by using Gover general dissimilarity, because here we are going to deal with both categorical and numerical. Now let's suppose I write here as numerical age. This person is 28, this person is 50. I write whether the person belongs to Bangalore or no. Yes, no. Which sports you like? Sports. It's written football and cricket. Which sports you like? So if you see this data consists of numerical value and categorical, and that too, it's not binary. See, we can write any value over here. It can be football, it can be cricket, it can be badminton. In this case, you can write any value. How you will find the distance? What we can do, we will set a rule. If the two numerical values, if the two categorical values are similar, if the two categorical, let me erase all this. If the two categorical values, we will write here, if two categorical values are similar, then we write distance as 0. If this if the two categorical values are dissimilar, then we write the distance as 1. If two categorical values are dissimilar, then we write distance as 1. Now what we can do? We will write these two are dissimilar. If these two are dissimilar, we can write distance as 1. If these two are dissimilar, distance is 1. Let's suppose I am writing male or more. Yes, yes. It means that if the two data are similar, we will write the distance as 0. If we write two data are similar, it means that the distance is 0. For numerical data, first we will perform scaling. You might know about scaling. When it comes to scaling, we are having different scaling technique. It can be normalization, standardization, or robust scaling. When it comes to scaling, we are having different scaling technique. It might be normalization, it might be standardization, it might be robust scaling. So if you write normalization, the formula is x minus x mean divided by x max minus x mean. Standardization, we can write x minus mu divided by standard deviation. In the same way, we also have robust scaling. It's x minus median. Here we have used mean. Mu indicates mean. The sigma indicates standard deviation. Here we are having x minus x median divided by IQR, interquartile range. So these are the different scaling technique which we perform so that we can scale down the data into certain range. This data might be in million or a million. If I want to scale down to 0 to 1, we will use normalization. Normalization help us in converting the data in such a way that the data will come under this range 0 to 1, 0 to 1. In the same way, scale, if when it comes to standardization, my data will lie from minus 3.4 to plus 3.4. When it comes to robust scaling, the data lies to minus infinity to plus infinity. So when it comes to robust scaling, when we have an outlier and we need that outlier in our data set, then we go for robust scaling. Otherwise, we will go for standardization and normalization. So let's go with normalization. We went with normalization and we normalize the data. Let's suppose the data after getting change, we are getting values as 0.2, 0.8. Now the distance between these two, we can write here 0.6. We got 0.2 and 0.8. Now the distance is 0.6. Now what we will do? We will assign weightage. Now to assign weightage also, we have certain criteria. If both values are given, okay? If both values are given, we will give weightage as 1. If any one of these values are missing, we will give weightage as 0. Here in this case, all values are given. Imagine that I don't have this value. If I don't have this value, we will give weightage as 0. Forgot about distance. If we are having weightage as 0, then we will not go and calculate the distance. Here, both values are there, then we will go weightage as 1. Here, both values are given, weightage as. Now, what we will do? We will use this robust general dissimilarity formula. So let's write robust general dissimilarity formula. It's okay. Summation of Wi into di divided by w. The weights into distance divided by weights. So for first case, we are having weight as 1 into distance as 0.6. In second case, we are having weight itself is 0. So anything multiplied by 0, we will get answer as 0. In third case, we are having 1, 1. 1 into 1. W3 is also 1 and distance is also 1. In fourth case, we are having distance as 0 and weight as. Now, we will divide it with all the weights that we are having. 1, 0, 1, 1. So, we are having 1 plus 0 plus 1 plus 1. Lastly, we are getting 0.6 plus 1 divided by 3. 1.6 divided by 3. So this is the distance between this person and this person by using Gover's general dissimilarity. See how we have converted any numerical or any categorical data and we are successfully able to find the distance between this. Now let's write down all the distance formula that we have discussed. So let's start with numerical. When it comes to numerical, we are having Euclidean distance. We are having Manhattan distance. And we are having Mahalanobis distance. When it comes to categorical binary data, binary, binary data like, for example, yes or no, true, false. These are all binary data. When we are having categorical binary data, we will go with binary Euclidean distance, simple matching coefficient, and then Jaccard's index. In the same way, what if we are having combination of numerical and categorical? If you are having a combination of numerical and categorical, we will go with Gover's general dissimilarity. You can write combination of categorical and numerical. We will go with Gover's general dissimilarity. So these are all distance formula that we are having. We will use any kind of distance formula in our ML model. These are the major distance formula that we are having. But most of the time, we will stick to either using Euclidean distance or Manhattan distance. Most of the time, we will stick to using either Euclidean distance or Manhattan distance. So I hope distance formula is clear to everyone, because if you understand the distance formula, then only we can understand what's going on in any ML model. So imagine that we are having this hierarchical cluster. We have this hierarchical cluster. We are trying to find the distance of one data point with all the other data points. So if you want to find the distance from here to here, the distance will be, see, here we are using Euclidean distance. So the distance will be Euclidean. Euclidean will be root under. For this we are having 1, 1. And for this we are having 2, 1. We will get 1 minus 1 whole square plus 2 minus 1 whole square. Here, sorry, this one will be, let's write the formula properly. We are having x1 minus x2 whole square plus y1 minus y2 whole square. So we will get x1 minus x2, x1 minus x2. 1 minus 2 whole square plus y1 minus y2, 1, 1. 1 minus 1 whole square. So finally, we will get distance as 1. So the distance between data point 1 and 2 is 1. In the same way, we will go and find the distance from 1 to 3. So to find the distance from 1 to 3, we need to know this is 1, comma 1. This is 4, comma 5. This one is 1, comma 1. This is 4, comma 5. Again, we will go and find the distance, Euclidean distance. Root under 4 minus 1 whole square plus 5 minus 1 whole square. We will get 3 square plus 4 square. That is 9 plus 16. Finally, we will get value as 5. 9 plus 16 is nothing but 25. Root under 25, you all know that it's 5. So we will get result as 5 here. In the same way, we will go and find the distance of each and every data point with all the other data points. Okay, in the same way, we will go and find the distance of each and every data point with all the other data points that we are. Once we got it, we will put it over here. If you see this matrix showcases the distance of one with itself. So we have studied that when we are trying to find the distance of one data point with itself, we write it as 0. The distance of one data point with itself is 0. The distance of 2 with 1, just now we have calculated. The distance of 2 with 1 is 1. The distance of 3 with 1 is 5. Just now we have calculated it's 2. Distance of 1 with 3 is 5. In the same way, the distance of 4 with 1 is 8.5. Distance of 5 with 1 is 7.2. Like this, we will go and find the distance of each and every data point with all the other data points. That's how we will get all this. Once we have calculated it, what we can do, we will go in this matrix, we will go and find which two data points are closer to each other. In this matrix, we will go and find which two data points are closer to each other. So if you see, 1 and 2 are the closest one, because all these are 5, 4.5 and all. But here we are getting values 1. If this is closest, what we can do, we will cluster down these two data and make it as one cluster. This will become my one cluster. After that, what we will do, once we have created our first cluster, now we will try to find the distance of all the other data point with this cluster. And we will consider the shortest distance, not the farthest one. We will try to consider the shortest distance between all the other data point with this cluster. So to find it, we will go and find distance from here to here and the distance from here to here. This is distance 1 and this is distance 2. So we all know that distance 2 is less as compared to distance 1. Distance from 1 to 3 is more as compared to distance from 2 to 3. So we will consider the distance from 2 to 3. We will not consider the distance from 1 to 3. So the distance from 1 to 3 is 5. The distance from 2 to 3 is 4.5. And what we have done, we have created this as cluster. 1 and 2 will become my one cluster and we put it as A. Once we have created cluster of 1 and 2, we will try to find out the distance of this cluster with this all these 3. And we will try to find out which distance is the closest one. So here out of 5 and 4.5, 4.5 is the closest one. We have written 4.5. Out of 8.5 and 7.5, out of 8.5 and 7.8, 7.8 is the closest one. So we will write 7.8. Out of 5 and 1, 2, this 7.2 and 6.7, we know that 6.7 is the closest one. We will write 6.7 over here. Like this, we will go and create a cluster. So once we have created this, we will put all this as it is. Okay, we will put all this as it is. So what we have done, we have gathered the smallest out of this. Here the smallest is 4.5. Here the smallest is 7.8 out of these two. Out of these two, the smallest is 6.7. And we will put it over here. Once we put it over here, we will simply copy this data, paste it over here. That's how we are getting this matrix from this big matrix. After we got it, we will again go and try to find which one is the smallest out of this. Once we find it, we will go and find which one is the smallest out of all this. So we get to know that 2.0 is the smallest one. Then what to do? Once we got it, again we will try to cluster down 4 and 5. Because we got 4 and 5, the data point 4 and 5 is the closest one after 1 and 2. Then we will try to cluster them. Once we clustered them down, once we have clustered them down, Then again, we will try to find which is the shortest out of, because we have clustered them. Let's make it big. What is the shortest distance between A, data point A, and this B? What is the shortest distance between data point A and this data point B? So we will select out of these two, 7.8 and 6.7. Here we will get to know that 6.7 is the shortest one. In the same way, we will go and find what is the shortest distance between this cluster, cluster B, and data point 3. So to find it, we will again go and find 3.6 and 2.2. So we will consider this 2.2 and we will discard this 7.8 and 3.6. And again, we will create this. Finally, we are getting this matrix. Out of this matrix, again, we will perform the same thing and check which one is the shortest distance. From this matrix, we will go and try to figure it out which one is the shortest one. So if you see here, 2.2 is the shortest one. 2.2 is the shortest one. It means that we are going to cluster 3 and B. Okay, it means that we are going to cluster 3 and B. So to make a cluster of 3 and B, again we will go and see what is the smallest distance between A and 3 and B. Because we have clustered down 3 and B together, we will try to find which is the smallest distance between data point A and 3 and B. So this one is the smallest one. This one is the smallest one. We will discard this. We will discard this. And at the end, we are getting this final model, which showcase only data point as 4.5. So the main aim of hierarchical clustering is, let's understand what is going on in hierarchical clustering. If we write the steps that is involved to perform this process, we are having step 1. In this step, we will consider each and every data point as a single cluster. In step 1, we have not clustered down any data point. Here, if you see in this matrix, we have not clustered down. So for this, what we will do, we will consider each and every data point as a single cluster. You can write, consider each data point as a single cluster. We consider each data point as a single cluster. Once it's done, again, step 2. We will try to find out which two data point or which data point in the cluster of data points are nearest. Here, we are trying to find which two data point are nearest, which two data point or cluster of uh, data points are nearest. So once we figure it out, then again we will, in step 3, we will cluster down the nearest data points. We will cluster down the nearest data. And then we will follow this step 2 and step 3 over and again until and unless all the data points comes under one cluster. What we will do? Let me write it over here. Step 4. We will perform this task over and again until and unless all the data points comes under one cluster. We will perform this task over and again until and unless all data points comes under single cluster. All data points comes under single cluster. So this is the step that we have to follow when it comes to hierarchical clustering. That's how we will cluster down the data points. Now, till this is okay. But how many cluster we need? We need to find how many cluster we need so that our model will perform. And also my model need to know how many clusters we have to create. So to perform this task of how many clusters we need, we will create a dendrogram. This is called as dendrogram. Here what we will do? We will write all the data points in x-axis. It's 1, 2, 3, 4, 5. We will write all the data points into x-axis. After that, we will see which all data points are nearest 1, 2. So we have understand that this one is nearest. 1 and 2 are the nearest data point. We will create a bar kind of thing. Group them together. In second stage, what we find? In second stage, we get to know that 4 and 5 are the nearest one. If 4 and 5 are the nearest one, we will make a bar. So this bar is little bit more bigger as compared to the previous one. Now once it's done, again we will go and try to find out the distance between 3 and B. Here we are trying to find which two data points or a cluster of data points are nearest to each other. So to find it, we will understand that 3 and B are the nearest one. If 3 and B are the nearest one, again we will go and create a cluster. And at the end, we will cluster down all the data points. So this is the dendrogram that we have created for this hierarchical cluster. Now, what is the use of dendrogram? Dendrogram help us in finding how many clusters we need. Okay. Dendrogram help us in finding how many clusters we need. So here in this case, how to find it? To find it, we will go and try to find which vertical line is the largest one out of all this, which vertical line is the largest one, which is not intersecting. Okay, we are trying to find out which vertical line is the largest one and which is not intersecting. So if you see, this one is the largest vertical line. Okay, this one is the largest vertical line, but this vertical line is intersecting. See, we can intersect it with this horizontal line. Now let's see which one is the second largest vertical line. If you see, this one is the second largest vertical line, but we can intersect it. See, it is intersecting. By this horizontal line, we can intersect it. What about this two? Here, this two we can also intersect. From this vertical line, we can intersect. What all line left? What about this line? See, this line we can't intersect by using only any horizontal line. This line we can't intersect by using only horizontal line. So what we will do? Here we will create a horizontal line by ourselves. Here we will create a horizontal line by ourselves. Sorry, vertical line by ourselves. Once we create this vertical line to intersect this, we will get two intersection. Here in this case, we are getting two intersection. If you are getting two intersection, it means that we need to create two cluster. Okay, if we are getting two intersection, it means that we need to create two cluster. And once we create the cluster, we will try to figure out whether the cluster done by the model is correct or not. For that, we have evaluation metrics, like we will go for to check Silhouette score and all. So think like you can take an overview that we have one matrix by which we can try to figure out whether the clustering done by the model is correct or not. The name of that is Silhouette score. We have different technique, like we are having Davis-Baldwin index, uh, Silhouette score and all. And we get to know that we are having a Silhouette score, let's suppose 0.8. It's a good Silhouette score. But still we will go further. We will go further downward and we will see for this. If you see for this, here at 3 point, we are getting an intersection. At 3 point, we are getting an intersection. Now what we will do, again we will go see the Silhouette score for this 3 intersection. 3 intersection means we are going to create 3 cluster. Okay, if we are having 3 intersection, it means that we are going to create a 3 cluster. And again, we will check whether the cluster done by the model is correct or not. That's how we will determine how many clusters we need. Here, when it comes to hierarchical clustering, we don't have to keep manually feed that how many clusters we need. The hierarchical cluster by itself will figure it out how many clusters it needs by creating this dendrogram. Now, to figure it out, the distances between one data point and a cluster, we are having different linkages. So to figure it out, how many the distance of one data point with other, we are having different linkages. So let's first discuss about, because it's very difficult to find the distance of this data point with this cluster. Difficult to find the distance of this data point with this cluster. So to find it, we will have different linkages. So let's first discuss about our first linkage. So this is Silhouette score. by using this, we can go, go and find whether the cluster done by the model is correct or not. Now, to find the distance of one data point with a group of data point, we are having different linkages. So the first linkage that we are having is single linkage. Then we are having complete linkage. After that, we are having average linkage. And at the end, we are having centroid linkage. So let's first discuss about what is the single linkage. Okay, we will discuss about what is this single linkage. In single linkage, imagine that we are having two clusters of data, clusters of data point. This is my first cluster. This is my second cluster. Now, if I try to find the distance of the smallest distance between these two data points, like finding the distance from the smallest nearest data points, this we call it as single linkage. If I find the smallest out of this, we will have a single linkage. Call it a single linkage. If you try to find the distance, farthest distance from this data point till this data point. Okay, if I try to find the farthest one, we call it as complete linkage. If we try to find the distance from the farthest data point, we call it as complete linkage. In the same way, imagine that I want to go with average linkage. In average linkage, what will happen? We will consider this data point, find the distance of this data point with all the other data point that is present in another cluster. Okay, let's write D1, D2, D3, D4. So D1, D2, D3, D4. Again, we will go find the distance of this data point with all the other data point that is present in another cluster. Again, we have written D7, D8, D9, D10. Again, we will follow this process over and again for all the data point that is present over here. It means that we are trying to find the distance of each and every data point present in cluster 1 with each and every data point present in cluster 2. And then divide it with the number of clusters, number of data points. Divide it by number of data points. This will give you average linkage. Okay, what we have done? We are trying to find out the distance of one data point with all the other data point that is present in the image or in scatter plot, and then divide it by the number of data points that is present over there. This will give you average linkage. Okay, this will give you average linkage. In the same way, what if I try to find the distance of one data point? Like, what if I want to find the centroid of this cluster. If I go and find the centroid for this cluster, let's suppose the centroid is lying over here. In the same way, what if I went and find the centroid for this cluster? The centroid will lie over here. Imagine. Then, if we find the distance from the centroid of this cluster with the centroid of this cluster, we call it as centroid linkage. That's how we can easily find the distance of one data point with another data point, one cluster with another cluster, one cluster with another data point. So like this, we will easily find by considering these linkages. So this is what we have for today. Let's revise what we have discussed in today's session. We have discussed about what is AI. We discussed that what is AI. Inside the umbrella of AI, we have ML. Inside the umbrella of ML, we have DL. Inside the umbrella of DL, we have GenAI. When it comes to AI, it helps us in automating human intelligence. It helps us in finding how human beings think. When it comes to ML, it helps us in finding the hidden pattern present in the data without being explicitly programmed. ML helps us in finding the pattern present in the data without being explicitly programmed. In the same way, we are having DL. When it comes to simple machine learning model, we have to deal with structured data, the data that we can store in its tabular format, in its raw form, then we call it as structured data. But what about unstructured data? What about image data, audio data, video data? So to deal with all those data, we come up with an idea of deep learning. We are having deep learning concept to deal with this unstructured data. Then after, what if you want to generate those data? What if you want to generate those unstructured data, like generation of image, generation of audio or video? To perform all these tasks, we are having GenAI. Then after, we get to know that we are having different distance formula which help us in creating the clusters. Okay, before that we have classified our ML model. We have classified our ML model. ML model is getting classified into basically three categories: supervised, semi-supervised, supervised ML, unsupervised ML, and reinforcement learning. Now, when it comes to supervise, we get to know that when target is given, y is given, we will go for supervise. When y is not given, we will go for unsupervised ML model. And when we are not focusing on feeding the data to the model, then we will go with reinforcement learning. Then after we get to know that what is the structure of supervised machine learning model and unsupervised machine learning model. Here, when it comes to supervised, we split the data into two parts: train and test. Again, train get classified into two parts, get distributed into two parts: train and validation. And then we feed only the trained data to the ML model and then go with validation to check what is the accuracy that we are getting for the model. When it comes to supervise, we will directly feed all the data to the model and then it will create a cluster of data. Create cluster of data. Then after, we have studied about different distance measurement. We have studied about for numerical data, we are having Euclidean distance. Then we are having Manhattan distance. And finally, we are having Mahalanobis distance. When it comes to categorical data, we are having binary Euclidean distance, then simple matching coefficient, and finally Jaccard syntax. And we also understand the formula behind all the distance. And lastly, we discuss about categorical and numerical combination. Here we come up with Gover's general decision. After this, we have talked about linkages. In linkages, we discuss about single linkage. Then we discuss about complete linkage. Then average linkage. And finally, centroid linkage. After that, after this, we get to know about our first ML model, that is hierarchical clustering. In hierarchical clustering, we discuss about the different steps involved in performing those hierarchical clustering. Like at first, step 1, we consider every data point as a single cluster. As a single cluster. Then step 2, after considering, we will cluster down the data according to the distance. And we will perform this step over and again until and unless all the data points comes together. At the end, all data point comes together. And to perform this task of hierarchical clustering, we came up with an idea of dendrogram. We have created dendrogram, and then by creating this dendrogram, we figure it out how many clusters we actually need for hierarchical cluster. And to check whether the model is performing best or not, we come up with Szilard score. So this is all what we have discussed. In tomorrow's session, like day after tomorrow, of course, tomorrow is holiday. We don't have session tomorrow. Day after tomorrow, We will again start with our unsupervised machine learning model. Like we will discuss about k-means clustering. Then after we will discuss about DB scan, and if time permits, we will also discuss a little bit about uh, recommendation engine. So this much for today. Thanks for joining everyone. PDF, yes, I can. But how to send it? Like I don't have, we can't send it through this chat box. We need something. I can share you the link and all, but here it's not possible. And anyway, we have not created any PDF. What we have done here is we have created this notebook to classify all this model and all. We have not done created any PDF. Okay. I will share it with in WhatsApp group. Definitely, I will share it with you guys. Anyone is having any issue? See, tomorrow we don't have session. Day after tomorrow. Yeah, of course, you can use it for your reference. Of course, I will share it with you guys. For that, you have to connect with your career counselor. I don't have that knowledge related to whether you are going to get certificate or not. Okay, then fine, everyone. Thanks for joining. I'm going to stop the session. See, if you guys have no doubt, you may drop off. If you have, you can pin me. But if you don't have, then you guys can drop. We will connect day after tomorrow.